Okay, that's good. So once again, sorry for the delay, and let me summarize the situation. Now, first of all, I am teaching this week today and Thursday. I cannot teach on Friday, but nevertheless, next week we will conclude the course. Next week I will teach on Monday, Thursday, and maybe Friday. I'm not sure. Okay, I'm not sure depending on not on my commitments, but on the progress of the lectures. So, it's clear, no lectures on Friday this week. Next week, as the normal schedule, may be that even next week I skip Friday, okay? But in any case, by the end of next week we close. I just would like to remind you that we decided to fix an exam on the May 26th, if I'm not wrong, let me, if I am. And again, I remind you that you need to subscribe to the exam of June 12, because I can record your results only after June, only on the exam of June 12. So basically, if you want to take the exam on May 26th, you have to send me an email, and I will make the exams in a chronological order based on the date and time of receipt of the email. Okay? Just to make a check, how many of you would like to take the exam the 26th? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I guess 11, 12 persons, but that's fine. I think we can conclude in one day. Okay, I think it is in the morning, so maybe, 12 persons, I need to move to the afternoon with some of them, but between the morning and the afternoon, putting the morning and the afternoon together, I will finish the same day. And this is confirmed, no change. Okay, as for today, now I move forward for about 1 hour with the explanation, and then I make a summary of the exercises. And on Thursday, I will tell you later if you need to bring the PC or not, because I have another exercise that I would like to complete, which I didn't present you yet before the end of the course. So I'm not sure whether I can introduce it on Thursday. I would say yes. If not, no problem. We can move to the next week in any case. Okay, that's it. Now, just to make a summary, let me go back to the problem that we are dealing with now. And we are dealing with decision theory. And within decision theory, I started to deal with multi-objective decision making, which is extremely important, as I told you, because very often in water resources management, our decision should meet not just one criteria, but at least 2, maybe 3, 4 criteria. So it's extremely important to know how to deal with decision making in the presence of many objectives. And I already mentioned to you what is the meaning of non-dominated solution, and I already told you, and you already know, that by identifying the non-dominated solution, you can reduce the number of alternatives. So if you have many decisions, even more than 2 criteria, many criteria, even more than 2, then you can identify the so-called Pareto frontier, which is the pool of the non-dominated solutions, non-dominated decisions, let's say, and therefore you can reduce the number of alternatives. So identifying the Pareto frontier, which is what we did during the last lecture, allows you to reduce the number of feasible alternatives. It doesn't lead you to take the best decision, but does allow you to reduce the number of alternatives, and then you concentrate your attention on the remaining alternatives. This is a brief summary of where we are, and now we have to move forward in the same context of multi-objectives. We have to move forward to identify the most appropriate solution. Okay, and of course the problem is not simple, because you have many alternatives, because you have many criteria. Of course, if you have just one criteria, then the alternative probably would be just one. If you have many criteria, of course, you have a number of alternatives. I mentioned to you that in decision making, it's often the case that we have more criteria. And for instance, if we refer to, I'm now going to introduce you an example which refers to the hiring problem, so the problem of identifying the best candidate for a position. Even in this case, you have many criteria like experience, like age, because you may want an experienced person, but also a young person. And often experience is conflicting with age. And many other criteria like the ability to speak languages, like the ability to solve conflicts among people, etc. And again, this is a very recurrent problem of several criteria. So how to solve it? Okay, there is a technique for solving this type of problems that is gaining more and more attention today, and the technique is the analytic hierarchy process, also called AHP. This page is taken by Wikipedia, so what I'm showing to you can be found in Wikipedia if you look in Wikipedia for analytic hierarchy process. And maybe that the Wikipedia page has been updated meanwhile, because this file was a printout that I took 1 year ago, more or less. Maybe 2, not more than 2, but maybe that it was updated meanwhile. And I'm bringing to your attention the Wikipedia page because I think it is really well done. Of course, it's not very detailed, and of course you can't read well here, so I'm just showing it to you here to provide you a reference. But then I will try to write on the blackboard with more details the essential features. As I said, the Wikipedia page is not much detailed, but provides a very good introduction and a very good narrative, and then the details will be given by me. So what is the concept in the analytic hierarchy process? The concept is to split a complex decision in a sequence of simple decisions. This is the concept. Again, the basic concept is to split a complex decision in a sequence of simple decisions. Like, for instance, if you have to choose between 3 alternatives, A, B, and C, the concept would be, let me decide between A and B first, and then compare the winners with C. This could be an idea. Let's suppose that, for instance, you have to identify what is among 3 runners, the one that runs faster, and you can't organize a competition with 3 people. You may organize a competition between the first 2 people, and the winner competes with the third. Of course, there are problems in doing this, you understand. It has to be well organized, because if you do like so, the winner of the first competition may say, I'm tired and can't run a second competition now. So this is just an example of a problem that you would have to solve. When you split a decision in simpler decisions, you need an analytical process to summarize the results. It's not just a matter of perception. You have to, of course, organize the process in a very rigorous way. But the concept is, again, to split a simple decision in a sequence of complex decisions. Opposite, to split a complex decision in a series of simple decisions. And this is an example, Wikipedia makes an example which refers to the hiring problem. So, what I mentioned before, the problem of identifying the best candidate to fill a position. And you may laugh, you may think that this is out of fun because they are presenting 3 candidates for filling a position, and then they are explaining how to identify the best. Of course, it's an example that it's not really pertinent to hydrology and water resources management, but I think it's a very good example, and it's relatively easy to change the context. So I want in the next hours, today and on Thursday, to explain to you how this can be done by referring to this hiring example, and then I will propose you an exercise which refers to water resources management. Okay, this document is very long, so I'm just summarizing what are the main features, what we need, and then you may want to read the entire document, but it's unnecessarily long, so I'm skipping the introduction, and I'm skipping all this sequence of pages that explain why multi-objective decision making is important, and etc. Which is anyway a good reading. Now, this is the rationale. It's explained in this sketch. You have to reach a goal. Goal is written in the green rectangle in the top, and then to reach the goal you have 4 criteria. And these 4 criteria, according to these 4 criteria, the idea is to identify for each criteria the best decision. And then, of course, then put the criteria together. In doing so, of course, you simplify the problem in each single step. What I mean to say, if you split the decision that includes 4 criteria in 4 decisions, each one based on 1 criteria only, you of course obtain the result that each decision is simpler, because you have now 4 mono-objective decisions. You still have the problem of finding a way to identify the best decision according to each criteria, but it's of course a simpler problem. But then you have a second step, which is putting together the results of the fourth decision, because of course, according to the first criteria, you may identify candidate 1. According to the second criteria, you may identify that the optimum is candidate 2. And then you have to put the result together. Compare 1 with 2 by, again, putting the results together. And it's clear that in order to do that, you need to assign a weight to the criteria. So you have to identify at the end of the story what is the most important criteria. If you want to combine the single results that you obtained according to each criteria, you have to find a weight for each criteria. I understand that what I'm saying is not completely clear now. Just try to make clear the overall concept, and then we will see an application. Okay? There is a second sketch which is simplified, that by using a reduced number of final nodes makes the sketch more compacted. The difference between the first and second sketch is just the fact that you see that in the bottom line here you have alternative 1, alternative 2, and alternative 3, and again according to the second criterion, alternative 1, 2, and 3. So you have the same alternatives that are repeated 4 times, 1 time for each criteria. And then a second sketch where, by using the same links, the results are compacted to a sketch that puts all the alternatives together. And here you see the names of the candidate, and also this is a more detailed sketch. You see what is the goal. Choose a leader. A leader means the candidate fitting the position, and in this case it's a leadership position. So for this reason I choose a leader above. And then the 4 criteria: age, experience, education, and charisma. Okay, charisma, as you may understand, is the ability of a person to be to exert an influence on people, the ability of a person to convince people that his vision is the correct one. Education, of course, is the ground, which is important for choosing a leader, and then experience and age. And these criteria, you see, that are a bit conflicting each other, because if you want a young person, probably this young person does not have a relevant experience, and maybe that doesn't have a very relevant charisma. And education may, at the same time, conflict with experience and charisma, depending, of course, on the behavior of the candidates. And then you see that you have 4 links connecting the goal, choose a leader with the 4 criteria, and for each criteria you have a link connecting the criteria with each of the alternatives. So the scheme is quite simple. But now we have to put this scheme in an analytical form. Basically, we have to find a way to perform a decision. Okay, now you see here an important step forward. Let me explain. You see that here in the nodes of this network, with the nodes, I mean the rectangles, you see numbers. These numbers are the weight which I introduced before. And these are also called priorities. Here they are called priorities. I treat priority and weight as a synonym. And basically, what do they mean? They mean that if you have to assign to each criteria a weight, and the sign of the weight should be 1. I prefer to use the term weights because it's implicit in the definition of weights that their sum should be up to 1. And basically, you can assign to each node of this decision network a weight. To the goal, you assign weight 1 because it's the goal that you want to reach, and you want to reach it with, of course, a weight of 1. But then this weight of 1 should be split in the 4th criteria, in the 4 criteria. And in this case, the split is in equal part, but this is, of course, just an example. In general, you will have different weights for different criteria. And now, the objective is at the same time to assign a weight or priority to the alternatives, to the candidates, because in this case, you're able to identify the best one. And even for the candidates, the sum of the weights should be equal to 1. So you have to start from the goal. The weight assigned to the goal is 1. And then you identify the criteria. The sum of the weight assigned at the criteria is 1. And then you come down to weights assigned to the alternatives. And the sum of the weights of the alternatives should be, again, 1. Of course, in doing so, basically what you did, be careful, is very simple. You split the amount of 1 that corresponds to reaching the goal in 4 parts, which are the weights assigned to the criteria. And then you transfer, again, to the candidates individual weights, which means, again, splitting the weight of the goal in individual weights that correspond to the candidates. To do that, you need to give an analytical relationship to the links. You may get the perception that it's relatively easy to assign the weight to the criteria. But then, of course, to assign the weights for each criteria to the candidates is not easy. This is what we have to how to split the weights among the criteria, could be done perceptually, and then we have, according to each weight, to split the weights among the candidates. This is the problem. Okay. Perfect. I think I can move to another file, again taken by Wikipedia. And this is a detailed explanation on how the decision is carried out. So basically, this is the part where we have to put our attention, to concentrate our attention. Okay. So basically, what is the first step? First of all, let's keep in mind that we already identified the 4 criteria, which are experience, age, charisma, and education. Okay? In our case, water resources management, we have a preliminary activity which aims to identify what are the criteria. And let me make some example. Let's suppose that you have problem that consists in identifying the optimal design flow for a water withdrawal. So you go along a river and you have to take some water for a specific use. Let's suppose that it's hydropower generation. And then you have the problem of identifying the design flow, which means the flow to which you design, for instance, the hydropower, I don't know how to say in English, the turbine or hydropower generator, let me say. And of course, this is a problem that is much relevant, much important, because if your generator is under design, then you have the problem that you can't use the water resources in an optimal way. If it is over-designed, it means that it doesn't work at the optimal flow, and also it's more expensive, and therefore you solve your problem in an efficient way. So it's extremely important to identify the optimal design for the hydropower generator. And in order to do so, what we do in general is to analyze and assess the temporal variation of the river flow, the flow in the river, in order to understand how many days along a year we have a given amount of water resources available. This is what we do usually. But there are several other features that impact the selection of the optimal design flow. And each of these features should be considered according to a criteria. Let me make an example. And first of all, let me say that these files which I'm using, these PDFs, are already available on my website. They were available already at the beginning. So I'm just now jumping to another file that is there. And this file, unfortunately, is in Italian. And it's not very relevant. I put it there because it's an example. But it's not absolutely a problem if you don't read it. So for the people that don't know Italian, I tell you, don't make even an effort. I am now describing why I am putting this file available, and my explanation just suffices for you. So this is a problem that is described in Italian, like the one that I just mentioned, producing hydropower by withdrawing water from a river. And I tell you the criteria that has been chosen. Yeah. And okay. So let me go back here. Okay, here we are. Yes. Okay, there is a first criteria, which is the impact on the people living close to the river. Because of course, if you take water from a river, you impact the people. Because there is a visual impact, people don't see water in the river anymore, and also there are some more practical impacts, like the fact that they can't use the river for fun, for having fun by bathing or to bring children, etc. And this is quantified according to an analytical relationship. And let's forget the detail about the analytical relationship. For now, I'm just interested in clarifying to you what could be the criteria that lead to a decision. Then there is an impact on the local wildlife, because of course, if you they are not talking here of fishes in particular, in general of wildlife, because of course reduction of the river flow causes an impact on the wildlife. And this again is quantified according to an analytical relationship. And then there is a temporary impact on the landscape, because when you build these works, when you work over the river, of course there is a temporary period which is more or less long, depending on the importance of the work, during which there is a visual impact. People looking at the river see cars, see trucks, and therefore, especially if the place is important from a touristic point of view, this impact is relevant for the population. And again, this is quantified, this is a temporary impact, but it's quantified with an analytical relationship. And then there is a permanent impact on the landscape, on the visual appearance of the river. Again, this is quantified with an analytical relationship. And then there is another impact which is due to the fact that the volume of the water storage along the river decreases. If you withdraw some water from the river, you have a decrease of the volume of water storage downstream, which means that fishes have less volume where to live. And this, of course, is a problem. It has an impact on the fisheries and on the quality of the environment. This, by the way, is strictly related to the geometry of the river, because in some cases, even you withdraw a significant part of the river flow, you don't have a decrease of the storage. It depends on the geometry of the river, basically. You may have just a reduction of the velocity of the flow, but not of the volume of the storage downstream. It has to be quantified, and in this case it has been quantified. And then there is an impact due to changes in the hydrological regime, because the presence of water withdrawal causes an attenuation of the variability of river flows. And then this has been quantified. There is an impact which is positive, which is consists of the reduction of the CO2 emissions, because if you produce hydropower, then there is a correspondent reduction, it's clean energy, there is a correspondent reduction of CO2 emissions, because if you produce the energy with other production methods, of course, you may have a release of CO2 in the atmosphere. And then there is another criteria, which is the amount of energy that is produced, and then another criteria, which is the economical benefit, and then another criteria, which is given by the economical benefit in the long term. Okay, you may say, of course, other two. Okay, there is another one, which is the rate of the economical investment, which means the rate which regulates the timing during which the benefit is, the expense is recovered. I'm sorry, this is a typical economical indicator. I cannot explain it in English very well, but it's not very relevant for us, so just don't worry for this. And then there is another indicator, which is hydrological, which is the functioning of the plant at the optimum flow. So what I mean to say with this example is just to explain to you that even in a simple decision like this, we have 12 criteria. So you see that, to identify the best solution is indeed a challenge. Okay, let me go back now to our previous slide. And let's suppose that we identified the relevant criteria. let me say that the identification of the relevant criteria is a problem that is more social than technical. And it's a problem that has to be solved with a consultation with the communities, with the local institutions, because of course the selection of the criteria is conditioning the final decision. If you just focus on criteria that evaluate the economic benefit, you get different results with respect to focusing on environmental protection, environmental restoration, etc. Okay. Now, once that you identify the criteria, the next step is to collect information, in this case, on the candidate according to each criteria. What I mean is that you have to collect all the information that you need in order to express a quantitative judgment of the ability of each candidate to meet each criteria. So in this case, you see you have 3 candidates and 4 criteria. You see that a matrix has been filled, which is a 4x3 matrix, which include all the information, again, I repeat, that allows you to quantitatively, numerically assess the ability of each alternative to meet each criteria. So, if we look at age, the information is very simple. It's the age of the candidates. If you look at experience, now you need a longer description, which is basically taken from the CV, in this case of the candidates. And from the CV, you distill the information related to experience. Preparing this matrix of information is an essential step for ensuring transparency and ensuring an objective evaluation. In the hydrological example that I showed you before, the information was summarized by the analytical equations that I just displayed to you and didn't analyze in detail. In that case, the information was given by an analytical relationship. Of course, the analytical relationship should be set up by using preliminary information as well. But let me say that the preliminary information is summarized in that case by the analytical relationship. In this case, you have this amount collection of information. Again, this matrix is extremely important. This is the way the decision process should be developed, by summarizing, efficiently summarizing all the information. Okay. This is, again, the cartoon summarizing our decision, the criteria, the candidates, and the type of problem at the top. And now, let me introduce the keyword. The keyword for completing this assessment is pairwise comparison. What is pairwise comparison? Pairwise comparison is an element of the analytical hierarchy process. Pairwise comparison, it's used when we need to identify the best alternative among 3 or more possibilities. The best alternative among 3 or more alternatives. example, if we refer to this problem of identifying the best leader, let's refer to one criteria, one of the 4 criteria. Basically, what we have to do is to identify the best candidate according to the considered criteria. But we have to identify not only this, we have to provide a numerical assessment. So we don't have just to identify the best one. We have to identify a mark for each of them. So even if we have clear what is the best one, we have to give him a mark and also a mark to the other 2 candidates. So for instance, if the mark of the best one is 30, then we have to give a mark to the other candidates. Why is this? Because then later on we have other criteria to consider. And at the end we have to put the result together. So we will get the mark that the candidate got with the first criteria, the mark with the second criteria, etc. So it's not just necessary to identify the best one, we have to give marks. The problem is that if you compare 3 people, to give marks according to the information that we put in the matrix, information matrix that I showed you before, to give marks to the 3 of them may be difficult, and even more difficult if you have 10 candidates. So the idea is to use pairwise comparison, which consists of comparing the candidates 2 by 2. So if you have 3 candidates, you split their comparison in 3 2 by 2 comparisons. Again, you are using the principle, the idea of